So after we introduce ourselves, we'll tell you a little bit about the company, and we'll get into the function and value of an EMI filter in this space. Then we'll dive into the details of the different applications and the filter requirements that go with them. We'll close by walking you through how you would select an EMI filter for your different projects. And of course, we'll close with our trivia prizes. The two people who get the most points are going to walk away with these lovely Black & Decker toolkits. I should note as well that the faster you respond with a correct answer, the more points you get. So right is important, fast is even better. And without further ado, I already told you that my name is Katie. I'm joined by two members of my very super team here, Anand and Anil. Anand is our director of product. He has been eating, sleeping, and breathing EMI filters for more than 18 years. And his superpower is that with just a few pointed questions, he can tell you exactly which filter you need for your project. Anil is one of our field applications engineers and a personal hero of mine. He has the inhuman ability to pop up wherever he's needed in the blink of an eye. So if you need any on-the-ground support, Anil or one of his comrades would be happy to be there with you.
Good morning.
Yeah, give a wave, guys. Anand and Anil. Thank you.
Morning, everyone.
We are here today representing Astrodyne TDI's EMI Filters business unit. As our name suggests, we do EMI filters for a variety of applications, including, of course, shielded rooms and facilities. We also do RF filters and power distribution units. We have two sister business units that help us make up Astrodyne TDI, high power and low power. And they do power supplies across the full power spectrum. Low power does anything up to about 1,000 watts. High power, aptly named, takes anything higher. I tell you that to tell you that if your needs in your project extend beyond EMI filters into RF filters, power distribution units, power supplies, our team here is ready and excited to help you meet those needs.
Hey, Katie, quick question. What product lines does EMI filter team handles? Are you going to explain about high power and low power? Are you going to explain a little bit on that?
Yeah, that's a good question too. So we do EMI filters as well as RF filters and power distribution units. So we call that the power tangential technology group. Anything that lives around power and helps you distribute or filter it, that's going to be us. And we are a technology-driven company. We consider ourselves technical partners to all of our customers. Our company headquarters and the bulk of our engineering team is located in Hackettstown, New Jersey. That's where Anand and I like to spend our time. We also have two facilities in China, one in Shenzhen and one in Kunshan. Those are production facilities with strong engineering support on hand as well. So wherever you are in the world, we've got somebody not too far away who can help build, design, validate filters for you. All right, and that allows us to get into the meat why you guys all joined us today, facility and shielded room filters. Now we're going to talk about several different applications within this space. Anand, can you explain how and why we've broken these up into the categories that we have?
Thanks, Katie. Sure. So when you're looking for a filter for any kind of shielded rooms, there are so many applications out there. Yeah, there are MRI rooms, there are commercial shielded rooms, there are test chambers, there are radio telescopes places, and there are server farms, and then there is a military application. So if you're looking for a filter, you go online and search. It's a muddy water out there. There's so much stuff. It's very hard to know which is the right product for you, and that's where you need help from people. Yeah, and at times it's hard to get folks on phone. Of course, we are not the same. We are always available. But to make life easy for our customers, we have broken the entire spectrum down into three specific applications. And when we go further up, you know why we have broken these down into these three segments. It's purely based on our product layout. So first segment is MRI rooms. Anything that goes into MRI room, whether it's with a power circuit, a signal circuit, has to be a filter. And we have unique products for that. And that's why there's a unique segment. Commercial, anything that's non-military and that's not MRI falls under commercial. Server farms, data centers, control rooms in radio telescope places, research labs, just of course test chambers. These are all commercial applications, and they do require some level of shielded room filtering. So that's the commercial space. And then anything that's military, it could be a test chamber, but if it's for military or anything else that's more like a secure facility, military base, and so on, that fall under middle gov, because again, the performance might be similar, but the products that are required are slightly different compared to what's needed in MRI or commercial. And we'll, as we go further, we'll see, we'll delve into it if you will.
That's a nice teaser. I like that a lot. And we are coming up on our first trivia questions, guys. So if you have not logged in yet and you want a chance to win, don't forget it's kahoot.it with the game pin in your bottom right. Oh, right now. Okay. So first question, what is the name of the new Mars rover just landed on Mars successfully last week? Very exciting. I know I was texting Anil when this was going on. It's very cool to watch it. We have 3 more seconds. Discovery, Columbia, Perseverance, or Curiosity? It is Perseverance, and most of you knew that. Fantastic. And we'll get to see our kind of leading scorers after every trivia question, so you can see where you are and who your competition is. Right now, Calvin J is leading us, top of the pack, followed by Jeremy, JB, Monica, and Michelle, well within striking range. Next question. What products other than EMI filters does ATDI manufacture? So the company as a whole, what else do we do? EMI filters for sure. Is it power supplies, power distribution units, RF filters, or all of the above? Should you have a need, how can we help you? Yes, all of the above. Again, most people knew that, so I'm glad. Thank you, Anand, for helping highlight that for us.
Sure.
Oh, Jeremy taking the lead. JB, both of you currently taking home a Black & Decker toolkit. Kelvin right behind. Michelle, EP. And which application does not require a shielded room or facility EMI filter? So we are going to dig more into the applications already, but this was on the last slide that we looked at together. Is it shielded tents, radio telescopes, PCB fabrication, or government embassies? 2 more seconds. Yes, PCB fabrication, absolutely. And we'll let Anand and Anil talk to us a little bit more about the shielded tents, radio telescopes, and government embassies we go through. Jeremy still holding number 1, JB with number 2. EP is coming up for you though. Michelle and AZ Paul not far behind. All right. Before we dig too deeply into the details of the different application categories, I think it's important to set a little bit of context. So Anil, can you start us off by telling us what an EMI filter really is?
Yes, thank you. Good morning to everybody, or good evening if you're on the other side of the planet. Before we talk about the purpose of a filter, we should probably highlight or understand what is an EMI filter. And as we talked about in the couple of slides before, it's essentially a blocking device. You can call it as a device that blocks the noise or mitigates the noise as well as possible. And the idea being to create an electromagnetically compliant environment, which means well insulated, well isolated, and that enables you to work or accomplish your mission properly without interference. And as you all know, for any of those systems to work, you need electrical power. So the filter has to enable providing that power, means it's a path, and also carry some signals in and out of the facility. So it's in a way you can say it's a blocking device or a mitigating device that works both ways. It attenuates signals or unwanted signals coming from the outside and prevents wanted signals or secure signals from going to the outside. So it's in a way it's what we call as a bidirectional device. And what is the purpose then of using this? Well, the idea being, as always, is you want to carry out your mission, a diagnostics or a research or some secure communication, without being interfered or interfering with others. That's definitely the integrity of the mission. Second, the information security. If you're processing a lot of data, you want that to be secure, the data to be, secure. And if you're doing a research or conducting a sensitive test, you want that to be done in a very clean test environment without interference from the outside. So the overall, the integrity of the shielded room is governed by the presence of a good filter. So the filter is fundamental to accomplishing all those missions.
Fantastic. Thank you. I know in some of our other webinars, we've talked about how filters are primarily used in different applications to prevent noise from going back onto the common power line. That was one of the most interesting things to me as we talked internally about the shielded room and facility space, is that it really is critical for filtering in both directions. Anand, can you tell us a little bit more about the purpose and value of an EMI filter in this space?
Sure, yeah. So as Anil was pointing out that filters are needed for clean environment. So first we have to understand what EMI is. It's a high frequency noise on the power lines or signal lines. Your power line is supposed to carry only 50, 60 hertz power signal. And anything other than that, that's on that line, which is 14 kilohertz or 5 megahertz or 10 megahertz or 10 gigahertz, is high frequency signals that are created by, digital processing, data processing, or, high speed switching, IGBTs and those kind of things these days. They create very high frequency noise and they travel on the power line. So inside the room where you're doing some sensitive data processing, signal processing, some experimentation, some sensitive research, you don't want this noise to come and interfere. So you put a filter, all the noise is blocked, and you have a clean environment. Nothing shows up on your scanner. Your scan is absolutely clean and has integrity. On the other hand, if you're doing something that's sensitive inside, if it's a sensitive data processing going on, or if you're working with some secure signals, and you don't want any of that processing to leak over the power line as high frequency signal, because somebody sitting outside could actually clamp onto the line, pick these high frequency signal and reconstruct what's been going inside. So that is the other side of the part, where this filter is blocking anything that's being generated inside the room from going out. So it's that's what it does. It creates a data integrity. So what is being done inside stays as is. Information is secure. Any information being generated inside the room doesn't go out. Clean test environment. If you're running some sort of test, you don't want any external information and external signals to show up on your scans or on your data. And shield integrity is the must, if you will, which is any penetration. When you create a shielded room is fully enclosed from all the sides. Nothing can enter. Anything that's hitting the walls is fully grounded. It goes to the ground. But if you make penetrations through the shield, now you have broken, compromised the integrity of the shield. So what filter does is, even if conductor is not a big situation for you, from the radiated standpoint, that penetration in the wall is going to allow any radiated signals to get in. So you mount a filter on top of that. So the power going in is clean. At the same time, you have covered that punch or the hole in the shield and got your shield integrity holding it.
Wonderful. Thank you. I know we have some people on the call today who are responsible for the construction of these special shielded rooms and facilities. So the value, the importance of an EMI filter that's not going to create a weak point in all the work and the construction that they put into that is certainly critical. And any product in any application is going to have specific regulations and industry standards that apply to it. Take a moment to acknowledge the standards that apply to EMI filters in this space. Anil, could you tell us about insertion loss first?
Yeah, thank you. As we just discussed, this blocking ability, how much it attenuates or how much it blocks of an unwanted signal, is a measure of how good the filter is. And rather than talk about it in very highly technical terms, we translated that to something called an insertion loss. It simply means how well it blocks or how well it stops. So the methods of specifying insertion loss have been rather well characterized and translated into very simpler terms, thankfully to lots of characterization that have happened in the past. and continue to happen. And they evolved into a bunch of standards. And the MIL standard 220, for example, and the CISPR 17. So these are good standards that have characterized both the content frequency and the level of signals needed for performing well. So this is what we call as an insertion loss. So to be able to measure them, we also need to know what they look like and hence define how much to be suppressed and attenuated. So that's what is generally categorized as an insertion loss, and we specify it in the form of a table.
Thank you. And Anand, can you tell us a little bit about shielding effectiveness and reliability?
Sure. Yeah. So what Anil was explaining just now about insertion loss is basically all the conducted stuff. Any high frequency signal that's on the power line getting into the room, filter literally blocks it. And as you said, this already been defined what it is, and you use MIL standard 220 or CISPR 17 to measure your filter to those specifications. Shielding effectiveness is radiated. Anything that's coming through, because EMI can be in air or on the power line. So anything that's coming through the air, you have a shield to protect your environment from that radiated noise. It hits the shield and gets grounded. Now, how do you measure the shielding effectiveness of your room? Again, if it's a fully enclosed environment, there are no pinholes, there are no cracks, there are no joints, you will probably get the highest possible shield integrity, maybe 100 dBs or 110 dBs. But there are penetrations, there are pipes, there are electrical signals, there are power lines getting in and out, there are doors, windows. So in order for all of that to be in place and still the shield to have its integrity, there are certain test standards that are used to measure the shield integrity of the room after it's fully done. So some of the common ones are IEEE 299, ASTM E1851-15, and MIL standard 285. There are, I'm sure there are other applications or the standards as well, based on the application, whether it's a room, whether it's a mobile shelter, whether it's a little test chamber. They keep changing, but they're pretty similar in nature in terms of testing. So any good filter will be able to pass when installed on the room properly with proper shielding practices, will be able to pass both the insertion loss and the shielding effectiveness test after the room is done. Now, these filters are on these rooms, and they're there for a very long time, 15 years, 20 years, because once you build a room, you don't dismantle it the next day. It just works for a very long time unless you have a necessity to expand it. Now, which means that anything that goes onto the room has to function for that long. You don't want to keep changing a filter every other year. So reliability is extremely critical for these filters. And for that purpose, the components are usually a little bit overrated. So 100 amp filter will probably have components that are rated a little bit higher than that. So it gives a little better reliability in the long term. And in order to achieve that, we use MIL standard 810 environmental practices, which means the filter is designed keeping in mind MIL standard 810 environmental practices so that it meets those requirements. Which is shock, vibe, humidity, fungus, and so on and so forth. So it's all taken into consideration. And MILPERF 15733, that's for component selection. So the components are derated based on that to make sure that the filter will continue to operate as rated and still have a very extended life.
Awesome, thank you. And Anil, can you take us home with a nod to safety?
Yeah. As you know, we just talked about where the filter goes. This is a path. So it basically connects to the grid that brings electrical power to the facility. So it is right in series with the power grid coming into your room. So clearly this filter cannot be the source of the problem or a hazard due to its current carrying ability or due to the blocking ability. So we have to ensure that it is safe. In other words, if you are a contractor of a building and you're doing a turnkey job, you're going to take on building the whole thing. But if you don't ensure the safety of that particular filter, then you're compromising the safety of the whole facility. So to translate the code requirements and the safety requirements down to some simple rules, design rules, there's these beautiful standards. The UL 60939 that we listed here is one good example. So the standards specify what kind of voltages should be used for how much of current you need and how much of spacings you have to maintain between two voltage points, etc. So it's a really, in one way to say that these are rules to ensure that the filter itself is safe and it doesn't become the source of a hazard while it is operating. for a long time, years down the road.
Wonderful, thank you. I'm trying to practice some good Zoom etiquette. I think my neighbors are having some extensive renovations done today, so sorry about that. All right, some more trivia. So a fantastic radio telescope down in Puerto Rico, currently under repairs, Arecibo. Is this a good application for shielded room and EMI filters? Is this the kind of application that we were talking about earlier, something we're going to dive into in just a moment? Or would they pass on EMI filters? Yes or no? Yes, it is. And we are going to talk about radio telescopes as an application here shortly. See, Jeremy holding very strong, JB as well. Michelle is coming for you though, AZ Pop and Scott. Another trivia question. What is the primary purpose of an EMI filter? Anil talked us through this a second ago. Is it to mitigate audio noise? Is it to collect your data? Is it to ensure that a building has power, or to block unwanted EMI signals? Anil and Anand actually both walked us through this a second ago. The primary purpose of an EMI filter. That is to block unwanted EMI signals, absolutely.
Yeah, so I would like to, some people answered mitigate audio noise. So just want to clarify, that's a good actually point to make an observation. When we say noise, a lot of people think we're talking about audio noise. No, we are not. Noise in the terms of filter is electrical noise, is the EMI. High frequency electrical signals over the power lines are also called noise. So let's not confuse that with the audio noise. Audio noise is the audible frequency range. This is way beyond that. This is 14 kilohertz and up. So this is called noise, but it's EMI, electrical.
I think you're going to talk to us a little bit about the different types of filters as well, and the filters that we might use for data security on an audio line, and how they're designed specifically not to impede the audio that's coming through, but only to act as a filter. Is that right, Anand?
Yes.
That's right. All right. Which of these common standards regulate safety? This was one Anil just gave us. Is it CISPR 17, IEEE 299, UL 60939-3, or MIL Standard 810? Which of these are a safety regulation? We did just talk about several of these. Which one was safety specific? Yes, it is the UL 60939-3. What was CISPR 17 for, guys?
Was that? CISPR 17 was for insertion loss measurement. So we talked about four things: insertion loss measurement, that's one thing, conducted; then radiated insertion loss measurement, which is shielding effectiveness. Third was how you build the filter, reliability part. And the fourth one was safety, which is UL 60939. So those four things are critical, keep in mind.
Jimmy and JB.
Yay, Jeremy. Yay, JB. You guys are doing great.
Yeah.
And Michelle, of course, right behind them.
Yes, just waiting. You guys slip up, Michelle's coming for you. Okay, so now we get to look at the applications in a little bit more detail. We'll start with MRI rooms. Now, Anil, if you were responsible for designing or constructing an MRI environment, where would you need EMI filters?
Good question. In fact, if you look at that image, it suggests a lot there. As you know, the MRI facility has to perform some very sensitive, highly sensitive analysis, pick up from very sensitive signals from body parts, and then display them or analyze them. But it can't be done in a dark room. You obviously need a lot of lights there. And then as you see in the image, there's also an enormous load of electronic signal processing equipment and analyzers. So all of them need power. And while the room needs enormous amount of power to generate that intense magnetic field, there's also this plethora of equipment that need operating power. So the EMI filter is extremely critical in this environment because it has to handle enormous amount of power, at the same time has to block extremely highly intense interference signals within and without. So the two critical filters types that are needed here pertain to one, the power filter, which is power line, and then naturally the signal line also needs commensurate filtering. So we have two separate filters in this category. Anand can walk us through some more details about how this is accomplished.
Thanks, Anil. Yeah, so for MRI room, the key parameters are small profile. So anything that's entering an MRI room, as Anil said, has to be filtered because you don't want any of that noise to show up on your scan. Any noise coming in will show up on your scan, and your scan will be useless. So that's why everything, and they have a specific frequency range that they are interested in. It's not very broad. It's much narrower compared to the other applications. So that's why we can get away with really small profile filters. So then that's very well defined. That's why the critical part is to make a very small filter that meets just that frequency range. So very specific products for this application. That's why we make. Small profile and the quick availability. You're working on an MRI room. You have to go and put LED lights, and you need filters. You don't want to wait around for 10 weeks, 12 weeks, 14 weeks to get these filters and then finish a job. You want to get in, finish a job, get out. So quick availability is extremely critical. And from that standpoint, of course, we keep these filters, usually keep these in stock. Once in a while we get cleaned out, but mostly we keep them in stock. 059 series filter is uniquely defined for this application for all power line applications in MRI room, whether it's a auxiliary device, powering an equipment, a wall outlet, LED lights, even power to the MRI room. These power circuits don't draw a lot of power. They are anywhere between 15 to 20 amp circuits. So the range is 1 amp to 50 amp. The filters cover that, and that's nothing. We generally don't see anything beyond that. Very rarely we see something going past that. We have 1 line, 2 line, and 3 line filter, which means they can filter AC, DC, single phase AC, DC, and 3-phase circuits. Signal on the other line, again, very similar to power. Signal lines that are very defined performance parameters, very clear defined performance parameters for phone, data, signal, alarm, and control. So uniquely designed solutions for these, and 058 series covers that very well. If you know what you're looking for a signal line filter for MRI room. You know, if it's an alarm line application, you go to a data sheet, there is a part number that clearly says an alarm line filter, and it's going to perform that way. It's industry standard. There's nothing unique about it. So we made life easy for you. If you know it's MRI, you know if it's signal, you go to 058 series, you pick a filter, you're done. And if you need help, Anil and I can help you anytime.
Wonderful. Thank you, guys. And now we'll talk a little bit about commercial applications. Commercial is a pretty broad title. It's a pretty big bite. And now, can you tell us a little more specifically, what are the applications in this space?
Pretty big indeed. You know, we've all gotten used to the world we live in, where we got enormous amount of interference right where we live and work. And as that image says, you got a car there, and obviously if you're driving in that car, you're creating your own interference. You got Wi-Fi's and Bluetooth, and then the cell phone signals coming back and forth. So all of that, how do we know are working well? How do we know that they're not interfering with each other and compromising the safety and performance of each one of them? The answer lies in that high quality chamber, and that facility is governed by how well it is performing the tests of individual items, so that they're all secure and do a good job. And naturally, you know, the level of performance required here is very high for test chambers and research labs, radio telescopes we talked before, and server farms, etc. So all of them again have different kinds of requirements. One, that power has to go through them to operate the systems in there, as well as the enormous amount of signals and data that are coming in and going out. So likewise in the MRI application, we have similar very high performance requirements here as well. However, there are other metrics that matter in this market compared to the MRI. So let Anand elaborate on those.
Sure. Somebody has asked me about a 40 gigahertz filter. I'm just replying to them. Wait till the end. Yeah. So what differentiates commercial applications from MRI is the power need. A lot of these rooms have a lot more power requirements than typical MRI rooms, which go up to maybe 30 amps max, sometimes 50. These go up to 250 amps a lot of times. So if you see, or sometimes maybe a little bit more than that. These are bigger rooms, and as you can see, there are rooms that are used for testing aircrafts. So, you know, depending on what you're testing in there, the power need can change. And the insertion loss requirements also more comprehensive as opposed to MRI, which MRI has a very narrow band that they're interested in. When you come to commercial applications, the band really extends. There are applications that require 150 kilohertz to 10 gigahertz, 100 dBs. And then there are more intensive applications where they're looking for 100 dBs from 14 kilohertz to 10 gigahertz. So we have application-specific products for those. Our Powerline 057 series filter, 05701, does the more broader band performance, 14 to 10, and then 057/02 is slightly narrower than that, 150 kilohertz to 10 gigahertz. But as you can see, this is much more than what MRI filters do. So these are bigger filters, bigger, heavier, and perform better than MRI rooms. We have 1-line, 2-line, 3-line, 4-line filters, AC, DC, 3-phase, J, 3-phase Y, everything can be accommodated. And of course, if you need anything more than 250 amps, we have another series that we will talk about a little bit later that can be offered. As I originally mentioned, the signal line insertion loss requirements are very clearly defined. If it's a phone line, this is what it needs to do. If it's data, this is what it needs to do. If it's control. So we can use the same 058 series filters here as well. There are fewer circuits going into a shielded room, and you can use these 058 series filters that typically they carry one circuit. So you need one for, if you have two control circuits, you will need one for each. And that's good because you have fewer circuits going in. You can have multiple filters, being installed, and you're good to go.
Awesome.
One thing I forgot to mention is the reliability part is more critical here compared to MRI. I'm not that MRI filters don't have to be reliable. They are reliable, but because these filters are more often used, the amount of usage these filters get is much higher than MRI. That's why they have to be a lot more reliable compared to them. And of course, cost is a concern because the commercial application, the people don't have unlimited pockets, or so you have to be a little bit cognizant of the cost.
Yeah, that's fair. So it sounds like our commercial categorization pretty effectively captures anything that isn't the very specific MRI group or the MilGov that obviously is going to come with its own set of requirements. Is that fair?
Yep.
Awesome. I know ran us through what those were, so I appreciate that. I know commercial is always a big mouthful. So now we can turn our attention to MilGov, also a pretty broad categorization, but with its own unique requirements that go with it. So Anil, could you tell us what kind of applications within military and government operations are going to need an EMI filter?
Sure. As we all know that whether it's war or peace, there's always some amount of secure communications going on. Of course, if it's a real tactical situation, you're also talking about command control and intelligence. So all of these happen in secure facilities. And as the very first slide showed, there are hostile actors outside constantly watching. So it's needless to say that these facilities have to be extraordinarily secure, and the performance expectations are as high as the other two, if not better. But in this market, there are other priorities, and the military being a prime customer for this. Of course, embassies fall in similar categories as well. The requirements for producing them within the US is also important in this market. And however, on the performance side of things, the expectations from an environmental point of view, as well as the shielding effectiveness over a much broader range of interference in this market are important. So these are categorized thoroughly in different standards, and we have adopted those standards into our power line filters and signal filters, specifically designed for the mill and secure government applications. I'll let Anand talk a little bit more about how those are accomplished in this market.
Thanks, Anil. Yeah, so as in commercial application, what you're trying to do is you're trying to keep the noise mostly out, external noise from coming in. So you want to keep the noise out so that you can have a clean environment, and you can do your test or measurements or whatever you're trying to do in. Security is not such a concern. In military and government, it's both ways. There are instances where you don't want any noise to come in because you are doing very sensitive measurements and processes. So you don't want that to impact your work. On the other hand, some of this information is sensitive, as Anil pointed out, and you don't want that information to leak out over the power lines, as we previously talked about, in form of digital signals, and somebody can reconstruct it. So these filters do the same way, block both ways. But the key feature here, as opposed to the commercial application, is that commercial application, as we said, these are typically smaller, I'll say larger shielded rooms. MRI is smaller, commercial shielded room are typically same size or a bit larger. Military and gov, you will rarely find shielded room. There are sometimes, but then there'll be a slew of shielded room next to each other, or at times these will be full facilities. You're talking about 100 amps to 200. Sometimes the starting point is 225 amp breaker rating. That's where you start. So you're powering the entire building. That's one thing. And these MRI, the usage is less. Commercial filters get used a little more. These filters are powered on 100% of the time. So they have to be extremely reliable. There are applications where we heard that filter was taken out purely because they were going to upgrade it, the power rating, and it's been in service for 25 years. And that's the kind of performance customers are looking for. So extremely reliable. We use all the right practices to build this so that they meet those requirements. And in most applications, made in the US is a mandatory clause because these are going into, mil facilities, strategic command centers, US-based Navy bases overseas, US embassies. They want to use something that's made in the US. So all the money that's been spent gets down to American businesses. And of course, there's a safety and security angle as well. So in order to address that, we have F1960 series filters. Performance-wise, they will be 100 dBs, 14 kilohertz to 10 gigahertz, similar to one of our commercial counterparts, but they're built differently. And of course, they're made in the US. And we have both single and dual line box style constructions. And we also have cabinet style construction, wherein there's a cabinet and you have line inserts that can be replaced. So in certain applications, customer specifically asks for a cabinet. We need cabinet style body. So we have those products in this range that can be offered. As you can see, the power demands are huge. So we start at 20 amp, but go up to 2,500 amps for line. Some of the high current versions are rated to 600 volts AC, not just 480. They can be used in AC and DC applications, both as we originally mentioned. Now, in this case, if you go to signal line, you see a different part number, F15000 series. Now, as I previously mentioned, the performance specifications for phone, data, alarm control are very well defined. So the filters going in are exactly similar, performance filter, if you will. Of course, they're made in the US. But the way they're packaged is different. Now, you have a huge facility. You have probably 50 or 100 telephone lines going in here, several data lines going in there, your control lines, your number of fire alarms. Now, if you start putting this one 058 series filter all over the place, let's say if you can use a 058 that's either made in the US or customer allows you to made in China filter, you are talking about mounting hundreds of filters across. It's a mess. It's a lot of labor. It's a lot of effort, more chances for things to go wrong. So in this segment, what we offer is a 15,000 series cabinets. These cabinets can carry anywhere between 2 lines to 500 lines. So you can have to 500 lines being filtered from one cabinet. So you bring everything that you need to filter. It doesn't matter what the mix is. It could be more phone lines, less data lines, less phone lines, more alarm lines. We can manage that mix because all the filters look alike in terms of mechanicals. And let's say you have 500 lines, we can take a 500 line cabinet. We can insert as many filters as necessary for each type, wire everything into the box, and then you mount it on one location, and then everything after it's all filtered, everything gets farmed out into the entire building. So that is a unique part about how we package these single line filters in this segment.
So Anand, what is the maximum number of lines we have built in one part? Just curious.
Off late, I don't think we have gone past 50, but I do remember, in my previous years that I think we did one that was 200 lines. That's what I remember. And I heard somebody told me once that we built 500 lines once.
Well, contractors on this audience, please know there's no limit.
Yeah, you don't come across 500 line cabinets often. It's not very common.
Be a real facility.
Yep.
Yeah,
Maybe in the future.
absolutely. And a quick shout out to our operations team too. This is the Made in the USA requirement that you see here. We do maintain full production capabilities in our New Jersey facility, and the cost sensitivity that came with our commercial applications we just talked about. Often those are built at our China facility where higher volumes, lower cost products are fabricated. All right, some more trivia. I hope you guys are still awake and with us. Which ATDI EMI filter series can be both MRI and commercial applications? This is our signal line filters, right, Anand? Is it the F1960 series, the O57, O58, or F15000 series? What is common? It is the O58 series. Pretty even distribution there. More people got it than not. Don't worry, we are going to send you a copy of this presentation and a quick decision chart as well. That way, if you have a project and you're worried that a not a nil or asleep, I promise you they're not. You can always call them. But you could follow the decision tree down to figure out which of these series would be the right choice for you. Let's see how we did. Jeremy and JB still holding strong. Michelle's still right there. STEM is coming up though. And AZ Paul still on the board. Next question, true or false? U.S. military and government EMI filter solutions must be manufactured in China to ensure competitive cost. True or false? Are the MilGov filters built in China to ensure competitive cost? That would be a good way to ensure competitive costing.
Yep, cost is critical.
Yeah. Our strategic ops team is happy to explain that to you. Yes, but it is false because our US Mil and Gov options are typically have Buy America, Build America requirements. What's going on, Jeremy and JB? Jeremy's on fire. Congratulations, guys. JB and Michelle still right there. Stim AZ Paul on the board. Okay. So we said that we would walk through quickly how do you select exactly the right EMI filter for your application. This is something that somebody asked us about in advance. So we wanted to make sure that we gave it appropriate focus. So Anil, you're usually the first person or often the first person that customers talk to when they have a new project. Can you start us off? How would you start answering this question?
Thank you. As we know that the plethora of applications have all been nicely translated down into very simple selection criteria. And here we are with the most top three categories defined already. And the families of filters, as we know now, we have categorized them based on performance and of course other objectives like cost and country of manufacture, etc. So the user, or rather the person that needs to install it, ultimately has to only pick the top three categories: medical, MRI, commercial, or military or government secured facility. And once you do that, based on the type of power going in, we have to define what kind of configuration of the AC mains power is coming into the building. Obviously, you have to define the current rating. And more or less, we know the voltage of the facility, depending on where you are in the planet. And the operating frequency as well gets decided there. And once we put all these stuff, we can then home in very quickly onto the exact requirements. And Anand will explain you a little bit better on how the whole thing is simplified down to the last detail.
Yeah, so we have put this slide together as a cheat sheet for you guys. Our intent is to demystify the whole process of filter selection for shielded rooms. As I said, it's a crazy world out there. You go and search, you find all kind of filters, and you don't know which one is which. And you don't want to be expert on filters. You want to know what you need at a point and just pick the right filter. And you want some decision tree for you to go and pick the right filter and just go and do the job. What you guys do is probably your expert, and that's what you want to focus on. So what we have done is we have broken down the entire spectrum into three segments, which is MRI, commercial, and gov. So if you know what you need, which one of these you're working on, you immediately know which product lines you need to look at. So if it's MRI, you know it's 059 and 058 series. If it's commercial, you know it's 057 and 058 series. If it's MilGov, you know 058 typically or 057 are no good unless customer is willing to say, I can probably use a commercial made out of US filter. So you probably are stuck with a made in the US option. So now you know which product lines you're looking at. Now, along with that, if you have the basic electrical specifications that you're looking for, which is what kind of power it is, AC, DC. If it's AC, single phase, three phase delta, or three phase Y, because delta means 3 lines, Y means 4 lines. So you need to know you want to filter 3 lines or 4 lines. So that's a simple information on the front end. If you can get what's the breaker rating that this filter is going to support. Is it 100 amps, 225 amps, or is it 600 amps? If you know that, because then it makes easy for you to select a filter. Voltage, typically filters are passive components. It's not voltage dependent, but it's good to know, because if you're looking at a 600 volt filter, yeah, you will have to be careful, because we have to pick the right filter for that. Most filters are rated to 480, 277, 480, so not a big deal. And you can use it anyway below 480. You can use it for 100 volts, you can use it for 120, 208, it works across the board because it's a passive component. But once you go past maximum voltage, is 480, you got to be careful. That's why you need to know what the voltage is. Operating frequency, 50, 60 is not an issue. 50, 60, if somebody 65, if someone, there are sometimes 10%, 10% tolerance issues, and we say, oh, we need to operate between 45 and 55, 55 and 65. Yeah, it'll work. But if the operating frequency is 400 hertz, which is typically a lot of times we see in some military applications and especially aerospace testing, you got to be careful, because once you start pushing 400 hertz through the filter, you're talking about a lot more leakage and heating. So typically, there are considerations that need to be taken into cognizance before we specify a filter for that application. So we need to know that very clearly. And yeah, once you know all of that, country of origin becomes typically redundant, because if it's MRI and commercial, it's typically nobody cares. If it's MilGov, maybe in most cases US, but if your customers say, no, I don't care about in the US, then yeah, then you need to tell us, because then we can give you a more cost-effective solution, if you will, which is made at a cost-effective location. Well, the bottom line is, if you have this information, you probably don't even need Anil and myself. You can literally pick the right data sheet, go and say, I am looking for a 4x400 amp filter. It's a 480. Here we go. F so and so, and you're done. Or I'm looking for a commercial application, 100 amp filter. Oh, 057.10014.00, and you're done. So life becomes that easy. You don't even need us, but of course, if you need us, Anil and myself, you're always here. We'll help you.
Yes, I love to chat with you guys. I highly recommend that everybody else does as well, because you do make it really easy. But if for whatever reason you don't want to talk to Anil and Anand or myself, you can use the decision tree that we're going to give you. You could use this checklist. The website is also designed to kind of walk you through this process as well. But my preference, my recommendation would be still to talk to Anil and Anand. And this is why Anand said, oh, just wait. I'll let you announce your baby to the world, Anand.
Yeah. We have been contemplating this product line for a couple of years now. We have seen this, popping up here and there of late. We have seen more customers asking for a filter that works up to 40 gigahertz, and the reason being, there are more instances. For example, you're talking about 5G. You're talking about very high frequency components that are being tested. You're talking about really, very sensitive signal processing, high precision digital measurements. Some of the measurements really fall into the spectrum past 10 gigahertz. Now, if you cleaned your room up to 10 gigahertz, but not beyond, and you're measuring something that's over that frequency, you have a problem. So you need a filter that helps you up to 40 gigahertz. So your environment is clean up to 40 gigahertz, and you can keep your measurement in integrity. So we decided to, start working on a filter that gives you 100 dBs performance, guaranteed performance up to 400 gigahertz. With existing filter, it could be hit and a miss. Nobody can confirm, but if you have a well-designed filter, it will do that. So this is similar to our 057 series commercial filter. It's designed to give 100 dBs from 14 kilohertz to 40 gigahertz. It will be a little bit bigger than 057 in some instances, more robust electricals inside, and mainly more robust mechanicals, because what you're trying to do is you're trying to create good shielding. That's extremely critical at 40, because higher the frequency is, smaller is the wavelength. And all you need is a little pinhole for that frequency to pass through, and your input-output isolation is gone. So that's why you need extremely good mechanical and shielding aspect of the filter. So that's what we are working on right now. We expect to release it in Q2 2021. And as soon as it's ready, you guys will see a announcement from us.
Yes. And congratulations, Anand. I know you're excited to see this coming into the market.
Hey, look, we all are excited. Congratulations to the team who's working on it.
Now, there was a question about on this one from Renee. Can you address that?
Same.
You want to be available, same UL certification.
Yeah. So yes, all these filters will follow the same UL certification specifications or UL safety requirements as our 057 series filter. So both are exactly the same. Yes.
And if you guys have any other questions, definitely feel free to drop them into the chat so our experts here can answer them. I'm going to take you into the last couple of trivia questions so we can see who our winners are. Which are the key considerations of selecting an EMI filter? Is it the material finish? Is it the current rating? Is it the mechanical dimensions or the connection style? Which of these were on our kind of checklist cheat sheet for picking the right EMI filter for your application?
I like blue filters.
Yes, absolutely. Is the current rating spot on? Let's see. Oh, yes. Okay. So when you get the slide deck, all of these will be links. We would love to talk to you more one-on-one and get to know you guys and your projects, your team. So please reach out to us, our sales team. If this is interesting and you want some more information, you can follow the links to our website. There's great stuff on there. All right. If you'll answer the poll, then we'll see who our winners are. I'll have the winners revealed. Are you interested in attending some more trainings with our team here? Absolutely. Only if there's trivia. No, don't invite me. For love of God, never call me again. Or I don't know. All fair answers. Not pushing you in any one direction. Absolutely. Oh, you guys are so sweet.
Oh,
We had a great time. Thank you guys.
100%. That's very good.
We really appreciated it. And the podium, our winners. Third with an honorable mention is Michelle. You were so close. You'll have to come back and join us again. JB with number 2. And number 1, Jeremy. All right. Congratulations, guys. Thank you so much.